Let's take a look at example 2 of section 6.2. They ask us to find the t-critical value if the level of confidence is 0.98 and n is equal to 20. We will first do this in the TI-84 using the inverse t command. So we go to second, distribution, go down to choice 4, inverse t. If the level of confidence is 0.98, we need the cumulative or left tail area. That's found by doing 1 minus c divided by 2. 1 minus 0.98 is 0.02. 0.02 divided by 2 would be 0.01. The next input we need, you got to be very careful with this. Don't confuse n with df. Degrees of freedom is always 1 less than the sample size. So if we have a sample of size 20, then that should give us 20 minus 1, or 19, for the degrees of freedom. Go ahead and hit enter. And this would produce a critical t-value of positive 2.539. So 2.539. For those of you that have the TI-83 calculator, you would do this using the t-score chart. If we have 19 degrees of freedom, that would be this row here. And we said that we wanted the 98% confidence interval. So 19 degrees of freedom is here. 98% would be right there. That also produces a t-critical value of 2.539. Just go across the top level of confidence, 0.98, 19 degrees of freedom. Let's take a look at example 3. In a random sample of 5 people, the mean driving distance to work was 22.2 miles, and the sample standard deviation was 5.8 miles. Assume the random variable is normally distributed and use a t-distribution to construct a 95% confidence interval for the population mean, and then interpret the results. With this problem, they're pretty kind to actually tell us to use a t-distribution in the directions. However, not every single problem you're going to encounter, and this will be the case on some of the exam questions, is going to tell you whether to use ZC or TC. That's part of the expertise that we have to gain from this material. The reason why we will end up using a t-distribution, however, is first of all, go up and look at the sample size. We have a sample of only 5 people, so that's a small sample size. Furthermore, we only have the sample standard deviation. With a small sample size and the sample standard deviation, that's why we need to use a t-distribution on this one. Let's go through and calculate this one by hand. Just like what we saw before, most of the work in terms of calculating the margin of error is wrapped up in finding the critical t value. So let's do that with the calculator first. For those of you using the 84, it's going to be second, distribution, inverse t. If we want the 95% confidence interval, then the area is 1 minus 0.95 divided by 2. That's going to be 0.05 divided by 2, which is going to be 0.025. We have a sample of size 5, so that's going to produce 5 minus 1, or 4 degrees of freedom. Go ahead and hit enter, and to 3 places, this should give us a t-critical value of 2.776. 2.776. If we were to do this alternatively using the chart, we would go first to 4 degrees of freedom. That's going to be this row here. Across the top, we need to locate our 95% confidence interval, and that would tell us that the t-critical value for this problem would be 2.776. Same result we got as when we did the inverse t calculation. From there, we can plug it into our margin of error formula. E is equal to TC times S, that's 5.8, divided by the square root of n. So in the formula for E, we are using n. There's nowhere where the degrees of freedom shows up in the formula for E. It's divided by the square root of n, which was 5. If we punch this into our calculator and work it out, we would find a margin of error of 7.20. They already told us the sample mean, that x bar was 22.2. We now have the margin of error, so we're ready to compute the confidence interval. The confidence interval should be, first of all, in interval notation. You need parentheses. The lower limit and the upper limit should be separated by a comma. It goes from x bar minus e to x bar plus e. We take the 22.2, subtract 7.20, take the 22.2, add the 7.20, and what we would find is that our 95% confidence interval ranges from 15.00 to 29.40. The interpretation or the takeaway from this is we can say that with 95% confidence that we believe the true population mean is between 15 miles and 29.4 miles in which people drive to work each week. So it's not too bad. Again, the thing that's nice about this is a lot of the steps after you get past the fact that we're finding a t-score mirrors exactly the same kind of concepts we were doing back in 6.1. There is a command, and this command is in both the TI-84 and the 83, that will allow us to calculate this interval directly, much like how we use the z-interval command in 6.1. There is a t-interval command in the calculator that will do most of the work for us. If we go to the stat menu, go over to tests, and scroll down, this is in both calculators. The z-interval command is what we were using back in 6.1. The very next command below it, which is option 8, is a t-interval command. Let me go ahead and hit enter. Let's use that to double check our answer on this problem 3. We have two kinds of input options, whether we actually were given the raw data, which we weren't, or whether we have the summary statistics, which we do in this case. Since we have the summary stats, I'm going to make sure that this cursor is highlighted over top of the stats and hit enter to select it. I then can enter my sample mean. That was 22.2. The sample standard deviation was 5.8. Our sample size was 5. And we were asked to construct the 95% confidence interval, so our C level should be 0.95. I have everything in there. Let's go ahead and hit enter. And the calculator will compute the t interval for us. If I round all of these to 2 decimal places, this will round up to 15.00. And this one to 2 decimal places will be 29.40. Exact same result as what we got by hand. Let's take a look at another one. In example 4, they say your research driving distances to work and find that the population standard deviation was 5.2 miles. Repeat number 18 with the appropriate calculations and compare the results. Well, it's a lot of the same information. It's still the same sample mean, still the same sample size, but the difference this time is instead of having the sample standard deviation, we have the population standard deviation of 5.2. And the way that that's going to change things is when we go to construct our confidence interval, the margin of error formula this time will be done by finding a z critical value instead of tc. Now we'll be back to zc. If you wanted to do this by hand, we know that E is equal to zc times sigma divided by the square root of n. I would first need to find zc first, which you could do so by doing second distribution, inverse norm. The area here would be the cumulative area to the left when you're doing that z-score on 95%. 1 minus 0.95 divided by 2 is 0.025. It's the standard normal, so it would be 0 and 1. Go ahead and hit enter. And we've seen this a bunch of times now, but if it's 95%, the z critical value is going to be 1.960. We can go ahead and plug it in. That'll give us the margin of error E. That's 5.46. And then we do x bar minus E, x bar plus E, and that would produce our z interval in this case. We also, if you didn't want to necessarily work everything out by hand in the step, we could do the z-interval command that's located under stat. Go over to tests, choice 7, z-interval. The value for the standard deviation of the population was 5.2. Sample mean was still 22.2. We're still using a sample size of 5 and a 95% confidence interval. If we go ahead and hit calculate, that also produces the correct z-interval, 17.64 to 26.7